Hi, this video is about Einstein's theory of gravity. Have you ever been on one of those amusement park rides where it's like a spaceship or something that spins and you go inside and it starts spinning really fast and you get pushed up against the back walls? Well, it's sort of like the direction of gravity changes in that ride, whereas you no longer are you being pulled down to the earth, but you're being pushed up against the back of the ride. And that's sort of like saying gravity can actually be simulated. Gravity is not always down, it could be in other directions too. This idea is the same idea that Albert Einstein had when he developed his theory of gravity. So the way that he thought about it was, imagine that you're inside of an enclosed box where you can't see anything out of the box. So let's say that it's in an enclosed elevator, because elevators you can't see out of unless it has windows. So no windows. Imagine you're just inside of that elevator. And in the first situation that we're going to look at, let's say that you are weightless inside of the elevator. Everything in the elevator, including you, is just floating around. Now, what Einstein thought was there would be no way of telling from inside the elevator if you were falling through the air or inside of an elevator shaft free falling where everything is appearing weightless to you. There's no way to distinguish between this situation of being weightless falling towards the earth or being in the middle of outer space where you're far away from any gravitational forces. Well, that was interesting to Einstein because here there's clearly no gravitational force acting on you because you're floating, you're in outer space. But if you are falling to the earth, free falling, then clearly you are being pulled on by gravity, right? Because you're falling towards the earth, except you're weightless. You experience weightlessness in this situation. There's no way to tell which situation you're in when you're in the enclosed elevator. Okay, well, let's look at a second situation. Let's say that instead of being weightless, it's more normal, where you're standing on the ground of the elevator here, and you drop an apple and it falls to the ground. Okay, so this would be like saying, okay, I'm on Earth and I'm on the ground, right? So let's say you have the ground right here. Pretty simple situation. This is what life is normally like for us, right? You drop something, it falls to the ground. But Einstein said, well, wait a minute. This gravitational force could actually be simulated by taking your elevator to outer space, and instead of floating in outer space, you attach a rocket to the bottom of your elevator and you start accelerating upwards. If that were the case, if you were to drop an apple, it would still fall to the ground because you're speeding up this way. The apple's not going to stay floating there in space. When you're speeding up, you're going to keep speeding up. The apple is going to move to the ground. And so, according to you inside the elevator, how do you know which situation you're in? Is it gravity that's pulling the apple down? Or are you merely just accelerating through outer space? Well, Einstein said there's actually no way to know. And his conclusion was the effects of gravity, or the lack of gravity, are equivalent to the effects of acceleration. In other words, there's no way to know if you're experiencing gravity or if you're just merely accelerating inside of a gravitational field or in outer space. And so, what's the significance of this conclusion? Einstein realized that gravity is not really a force, like Isaac Newton said it was. Well, if it's not a force, then what is it? Well, that was his whole theory that we call today general relativity. And this is the basic concept of it. Of course, it's more complicated than what I'm going to cover in this video, but this is the basic idea and the concept of it, that gravity is not a force. Instead, it's actually just the result of the literal fabric of physical reality, space and time, being altered by massive objects like the sun or the earth. So another way that people often say and describe this is that mass will tell space and time, which together we call space-time, how to curve. So you place a massive object like the sun in space and time, and it causes space and time to curve around it or bend around it. And it's literally the fabric of the universe being altered by this massive object. Okay, so that's one thing. What's the significance of space and time being altered or curved? Well, space-time tells mass how to move. So as you're moving through space, how are you going to move? You're going to move in a straight line. That's what Isaac Newton said. Objects that are in motion will stay in motion until they're acted on by an external force. They're going to keep going in a straight line forever. Well, Einstein said, yeah, that's true, except a straight line within curved space may actually result in a circular orbit. You're still moving straight, but straight itself has been curved because the universe itself has been curved by objects like the sun, or massive objects like the sun or stars. So we now have a new explanation for gravity. It's no longer this invisible force that's being, kind of magically or unexplained pulling through space that there's no mechanism for it to actually pull on. We've moved away from that Newton's picture of gravity, and instead it's Einstein's model of space and time being curved. So if this were true, it seems pretty outlandish, pretty crazy for that to be the case, but if this were true, then not only would physical objects be altered in their path as they go around the sun, like the Earth would move around the sun. Okay, that's one part of this. But if this were true and space and time were actually being affected by massive objects like the sun, then light itself would also be bent, because light travels straight through space and time. And so if space and time are the things that are being affected, then that means that anything that travels through space and time would be affected. And that includes light, not just matter. So to test this out, we could have us here on Earth and the sun out here, and we could be looking for stars that are normally invisible to us. Because think about this, right? If we're looking here out towards the star, we're trying to see this green star over there. There are no green stars, but let's just say for this case there is. The sun is in our way. We couldn't see it. Now, obviously the sun is so bright we can't see stars in the daytime, but if we could somehow block out the sun, let's say we have a solar eclipse here by the moon, okay, and it casts a shadow on the Earth here, and we're in that shadow, could we possibly see that green star? Well, according to Albert Einstein, it is possible. Because the light from this star, while it shines out in all directions, it normally couldn't get to us by shining straight through the sun. But if the sun is actually curving space and time, then this beam of light that's traveling straight will follow a straight path that gets curved by the sun. And so from here, us on Earth, we can see this green star if Albert Einstein is correct. So is he correct? Well, this phenomenon of gravitational lensing, or the bending of light by gravity, was first observed by Englishman Sir Arthur Eddington in 1919. So this was confirmed to be true. This gravitational lensing happens. And we see it especially today when we look near galaxy clusters where there's huge amounts of mass. We see these amazing distortions of light that causes stars and other galaxies to appear completely ripped and bent by just simply passing behind or by another galaxy. So we see that this is something that actually happens. And not only this, but there are several other predictions that Einstein's theory of gravity makes that have been further confirmed down the line. That's not for the purpose of this video, but there are other videos out there that will help explain those. But that's all I've got for you in this video. Remember, today could be your last, so live on purpose.